Hello and welcome, the Network Berg here. Hope you're doing well. In this video, we will be looking at how to configure IPSEC VPN on Router OS version 7. So this is more or less an update of my version 6 video. It's just to show you how everything connects on version 7, and we will be using IKE version 2 for this setup, so this is going to be quite fun. If you're a new viewer, welcome to the channel. I'm just some random guy that covers a lot of MikroTik configuration, so please feel free to look at all of my other videos. Maybe there's something else you'd like to know. And if you're a returning viewer, welcome back, happy to see you again. Let's get into a short presentation followed by the actual live lab. Also, this all will be timestamped, so if you feel like you just want to skip to the live lab, go for it. See you guys in the video. Alright, so let's talk about IPSEC, and I've got a little, I think animation at the back here, which kind of encapsulates properly what IPSEC does, because it's going to form a tunnel, and inside this tunnel, we're going to be able to securely transfer our datagrams or our IP packets to another host or server or something securely, so that if that information ever was somehow gotten a hold of, the people that looked at it would just see garble, they wouldn't know what's happening. And so IPSEC is just a means of securing our IP traffic, and one of the common uses of it is to create VPN tunnels. So let's look at what is IPSEC. It is short for the Internet Protocol Security. So if you know TCP/IP, IPSEC was sort of just made as a way to secure our IP traffic. It is used for virtual private networks. It allows for, and this is very important, authentication and encryption between hosts or networks. Now, what that entails is people need to be able to authenticate, and once they've authenticated, then there's an encryption algorithm that will be run, and those encryption algorithms need to also just match in order for the data to be successfully sent and encrypted and decrypted between two peers. It works at the OSI layer 3, which means it works over IP, obviously, but what's awesome about it is it can be run over the internet. So a lot of times you'll find people will use stuff like IPSEC to create IPSEC tunnels to maybe like another ISP or to another company or to their own company, or even to something, this is actually pretty common and new use a lot, to a cloud provider. So maybe to like Azure or AWS, you could have a virtual environment there with servers and a virtual network and all that stuff. And then you could use IPSEC to create a tunnel from your own network to Azure, and then you'd be able to access all of those private subnets that's hosted with Azure over your IPSEC tunnel. So that is really, really cool. IPSEC also includes, let's say, a suite of protocols for establishing what we call mutual authentication. Now, mutual authentication just means that things need to match. So whatever you've configured on your side of an IPSEC tunnel needs to also match on your opposite end. So the person that you are connecting to, they need to make sure that stuff like a pre-shared key matches. They need to make sure that encryption details match. They need to make sure that Diffie-Hellman is specified correctly, because if there's any type of mismatch on IPSEC, and this is actually the reason why a lot of people dislike IPSEC, if one thing is not correctly configured on either end, the tunnel just will not come up. So this is going to cause a lot of heartache, because you configure the tunnel, your friend configures his side, and then one of you've made a mistake, and now you both need to troubleshoot and see that one of us maybe not ticked something or said something correctly. So that was where the biggest grievance comes from IPSEC, but it's actually such a silly thing, because it is actually quick to just figure out where the issue is if you debug properly and you see where the problem's coming from. A commonly used key exchange method, and this is a word I mentioned earlier, is Diffie-Hellman, and this is in essence just something that I can also just put a link in the description for you to review a little bit more in detail. But what you need to understand is the DH groups needs to match on both ends in order for an IPSEC tunnel to connect and communicate properly. And then lastly, IPSEC is an open standard. So this also, I don't want to say sets it apart from stuff like OVPN and WireGuard, because those are also open standard, but they're not as readily available on all vendors, whereas IPSEC is actually widely used. As I mentioned earlier, you can almost connect to anything with IPSEC, so that really makes it cool. And you've got different key exchange methods as well. So if you're using IPSEC IKE v2, then it's actually pretty fast as well. It's very secure, and it's also pretty modern. So don't think IPSEC is going away. It's still going to be around for quite a while. All right. Now I just want to talk about the IPSEC security architecture, and this is just kind of the components that makes IPSEC work, because firstly we've got authentication headers, which is just a header that gets slapped on top of your IP headers, and when you send that to your destination, it's just there to make sure that the authentication is correct between you and your peer. Then you've got your encapsulating security payloads, or the ESP. So think of this as the data integrity part. This just makes sure that nobody has tampered with anything in the packet and that everything is actually still in order and it looks okay and everything is where it should be. So this is just another form of security on top of IPSEC. And then lastly, we've got our Internet Security Association and Key Management Protocol. So this is a word you'll see a lot, but you also rarely see it. You'll see just security associations a lot. But in essence, what this means is this is just where we come down to our actual authentication part. How are we authenticating? Are we using pre-shared keys? Are we going to be using some form of a certificate? Like, how are we going to authenticate, and what algorithms are we going to use? And then matched off of your ESP and the SAs, your IPSEC tunnel will be formed, and if everything matches and is set up properly, then you should be able to send and receive data across an IPSEC tunnel. All right. And here I just want to mention some common IPSEC networks that you can see or deal with. And we've got stuff where we have a host-to-host connection. And this is quite typical, where you might have an application server that's maybe it's like a camera system or something, and people just need to be able just to connect to this camera system. You could set up a connection from one host to that camera system so that they can VPN in and just have access to that system. So this is host to host. The two hosts can communicate with each other. Then we've got host to network. Now this is actually very typical, where you might see it's more commonly used with stuff like dial-up VPNs or SSL VPN, where you might have a firewall and a user would dial in to the firewall to connect, and once they've dialed up, now they can connect and get to the rest of the network. So they've authenticated and they can actually access the file server, or they can get to a mail server, all that stuff. So this is where you'll commonly see host to network. And then lastly, we've got network to network. Now this is quite nice, because this will allow us to actually get to different subnets or different network addresses using IPSEC. So think of this as a secure way where you might have a remote branch, and all of your branches might connect to your head office, and then through your head office all of the branches can also connect with each other, so that you've almost got, I don't want to say an MPLS network because it's all going to be IPSEC, but you've got a secure way to access all of your branches remotely. So it enables you to get to your remote site securely without anybody being able to steal your data, because if everything just went over the public internet without any type of authentication like IPSEC, that might pose a bit of an issue. All right. So let's quickly talk about what we're going to be doing in this video. So I'm going to have a physical lab using Eve, or actually just my VMware in this case. And we will be configuring what we like to call a site-to-site VPN. But this will be that network-to-network VPN, where two networks will be able to communicate with each other. So you can see I've got this 172.16.10.0/24 network configured at site A. And then I've got 172.16.20.0/24 configured at site B. So both of these routers, in theory, they'll be connecting over the internet, but they're not going to just connect over the internet. We're going to use their WAN-facing IPs to establish an IPSEC tunnel. And then via this IPSEC tunnel, we will be able to actually connect with each other and, you know, get to a remote host from one end to the other end. So that is kind of the gist of what we'll be doing with the topology, and this is a very typical setup for IPSEC, so I hope you enjoy, and let's get into the physical lab part. So let's start off the configuration on site A, or TMB Lab 01 in my case, where we will be configuring the IPSEC. Now on MikroTik, it's a bit weird how you set up the IPSEC, because the tabs aren't structured in order, and every few version updates it seems like they change somewhere that you need to go to tweak something. So just take that into account when you are working with IPSEC. But this is on version 7.2.3, which is the latest version or stable version. So if we want to configure IPSEC, we go into IPSEC, and we'll put you in this IPSEC table. So you've got policies, proposals, groups, peers, all of these tabs that you can work with. But you're not going to start with the policies. You're actually going to firstly start with creating a profile for your IPSEC tunnel. So I'll go to the profiles tab, I'll click on the plus, and I can specify a profile. So I can call this IPSEC to, let's say, site B, we can specify a hash algorithm. So please don't use SHA-1. It's very outdated. I do recommend using the best one that you can. In this case, it's SHA-512. But if you are configuring a tunnel to somebody else, just ask them what hash algorithms do they have available. Because if they can't do 512, they probably can do SHA-256. So, but I'm just going to make it SHA-512 in my example because I have that available. Now we can set our encryption algorithm. So I'm going to take out the 3 DES, take out the AES 128, and I'll select AES 256. Now we need to specify our Diffie-Hellman group. So I will just make this MODP 2048, which is actually the Diffie-Hellman group of 14. So if you use the reference material, you can find out exactly what each of these options correlate to as a group number. And we're not going to change anything else here. We'll leave everything else to default. Just to build on some of the stuff, you do get like an option for NAT traversal, which just allows you to build the IPsec tunnel to something that maybe lives behind a NATed gateway. So this might be, let's say, in the example, if there was a user at their home internet, then obviously their personal computer is probably using a NATed address. So if they were forming an IPsec tunnel, there'd need to be some form of NAT traversal for that to actually work. Then we get stuff like DPD or dead peer detection, which is just a protocol there that makes sure that the IPsec tunnel is actually up or down. If it's down after 5 times, then the tunnel will just be marked as down. That's in essence what these extra settings mean, but you don't need to tweak them by default. They're all relatively the same, but if you're connecting to another vendor and maybe they have some different default value for one of these, just find out from them what it is so that either they can update or you can update. All right, so let's apply this. So all we did was create a profile, set our hash algorithm, encryption algorithm, and Diffie-Hellman group. That's all we did. Next thing is we need to specify a peer. So the peer will be where you're connecting to. Who is your friend that you're establishing the IPsec tunnel to? To which other router or firewall or provider or whatever are you actually connecting to on IPsec? So let's click on the plus. Now I can set the name here. So this I'll just make IPsec site. Let me just make it lowercase like the other one, site B. And the address will now be the either the WAN or whatever IP address that you're able to get to the remote side. But let's say this was over the internet for me. So I'm connecting to 172.16, even though this is a private address, we're just simulating it or acting as if it is. Actually, it was 31.255.210. And our local address, I'm not going to specify anything there, but here we can now set our profile. So here we must set what profile we created earlier. And now in the exchange mode, you can actually set, is this IKEv1 or 2? So if you set IKE2 here, it's IKEv2. And if you put any of these other values, it will be IKEv1. It's just one of the other options. But typically if you set up IKEv1, you'll just leave it on main on both sides, and that'll work just fine. Now, what's the difference between IKEv1 and 2? IKEv2 actually just is better for throughput. It's also just a more well-rounded protocol, and it also offers a lot more security. IKEv1 is quite dated. All right, so let's just apply this. And now after this, we need to set our identities. Now the identities, you can think of this as the place where we're going to specify how we're going to authenticate. Are we using a password? Are we using a certificate? What are we going to use to actually authenticate? So I'm going to click on the plus. Now we can specify our peer, which we created, and we can set the auth method. So if you've watched my NordVPN video, there you'd use something like EAP with a certificate to actually authenticate, but we will just use a pre-shared key, which means we will type in the password that we want. And now in the secret field, you can put in the password. Now it's very important to note, don't use some silly password that you just typed out in a text document. Like I'd recommend going to a key generator like Google Cloud. They've got key generators that is made for creating IPsec tunnel keys. So they can just quickly create a very nice, strong and secure key for you. You can copy that, and then you just need to share that key with your friend or yourself or whoever's going to do the setup on the remote end. But again, please don't just send it to them over email. Use some type of secure channel, maybe some type of encrypted file, like a RAR file that's encrypted that they need the password for to actually open it, to actually see what the password is, or send it to them over something like some more secure method. Don't just email them in plain text. That's kind of defeats the purpose. But let me just make my secret TMB123. I'm just doing this for demonstration. And that's all I'm going to do. I'm just going to set my peer and my secret. I'll hit apply. So now the identity is set. Two more steps that we need to follow is we need to set a proposal, which is similar to the details that we filled in on the profile side, but this is now the proposal that we're going to be using for our specific policies. So in this, I can just call this the IKE v2 dash proposal. Now we need to set our auth algorithms again. So I'll just make that SHA-512 and my encryption algorithms, which was AES256. And our PFS group, which is the Diffie-Hellman, we'll just make 2048. I'll leave the lifetime default. But again, if any value doesn't match, even the lifetime, the tunnel ain't going to work correctly. So let's just apply this. And now lastly, we can finally set our policies. Now the policies is where we determine what we're going to send and receive over this IPsec. So we'll click on the plus. Now in the general tab, we can set a peer. So our peer needs to be the peer that we specified earlier, so IPSEC Site B. And this tunnel button, make sure that you tick this. If you don't tick this, then you can't actually specify remote networks here. Then it's just going to be like a host-to-host communication. So let's set the source address, and in my case it is 172.16.10.0/24. That is my local subnet, and the destination address is the remote subnet I would like to get to. So that is 172.16.20.0/24, and I'll allow all protocols. And I'll go to my action tab, and in action, make sure that it is set to encrypt. It usually is. And then at the bottom, you'll see there's a proposals option. Just click on that and select the proposal we just created. I'll click on apply. And that should be it. This is the basic setup on the one router, but we won't see that anything is actually working yet. Here we can see it's trying to connect, but it's actually not doing anything yet. So let's make it work by actually going on to the command line of the second router. And from here, we will just do the configuration quickly from the CLI. It's really not going to be that bad. Don't worry, guys. So let's just make the screen a bit bigger. So I just want to put it in a way that my face doesn't get in front of the commands the whole time. So let's just stretch this out a little bit. That should be good. All right. So first thing we want to do, we want to create a profile. So IPsec profile. We're going to add it. Now we can give it the name. So the name was IPsec-site-A in this time because we're connecting to site A. And let's just see, we want to set our encryption algorithm, which is AES-256. We want to set our hash algorithm, which is SHA-512. And we want to set our DH group, which is MODP2048. And let's just see, is there anything else we're missing? Everything looks good, so I'll just hit enter. Next step is we want to create our peer. So I'll do an IPsec peer add. The name can again be IPsec-site-A. And we're going to specify our profile, which is the profile we just created, which was the IPsec to site A. And we need to set our exchange mode, which is IKE2. Is there anything else I'd like to add? Oh, and our address, obviously, where we're connecting to. And in my case, it's going to be 172.31.255.1. Perfecto. Let me hit enter. Next, we'll set our identity, which is for the authentication. So we'll do IPsec identity add. Now we can specify our peer, which is the peer we've created, IPsec-site-A. And we need to set our secret, which is the password that the two devices are using. So in my case, that was TMB123. And then I'll just hit enter. One cool thing I want to show you, if I do an IPsec identity and I export that, it does not show that secret. This is for security purposes. So if you forget what that password is and there's a password issue, you need to just reset the password. It's just so that people can't extract that information if they do get a hold of getting into your router board, which is actually quite nice of MikroTik, if you ask me. All right, two more steps: policies and proposals. So let's just first do the proposal. So we'll do IPsec proposal. add. We can give it a name. So this might be my IKEv2-proposal. We can give it the auth algorithm, which is SHA-512. We can give it the encryption algorithm, which is AES-256-CBC. And we will give it a PFS group, which is the Diffie-Hellman group, which is MODP2048 for me. And there's nothing else that I see that I'm missing, so I'll just hit enter. And now we can finally set our policy. So IPSEC policy add. Now, first thing I want to do is select my peer, which is the IPSEC-site-A. Then I need to just make sure it is set to be tunnel. Then I can set my source address, which is going to be 172.16.20.0/24. My destination address is going to be 172.16.10.0/24. My proposal is going to be the one that I just created, the IKEv2-proposal. And let me just see if there's anything else that I want to add. Everything looks fine. Sorry, I need to just make sure my action is encrypt, but it is that by default. And let's hit enter. So if I do an IPSEC export, this should be all of the configuration that we added, and this should be fine. So let's just go back to Winbox, and I can already see my PH2 or my phase 2 state is established, so that is pretty good for me. If I look at my active peers, that is awesome. We can see we do have an active peer. The state is established. We can see what the local and remote addresses is. Think of this as the WAN addresses of what's communicating, what the uptime is, and how many bytes have been sent and received over this tunnel. Awesome. We can also look at the installed security associations. And here we can see basically what encryptions are being used and all that good stuff. So yeah, this has been set up. This should actually be working. So to test this, I'm just going to go into the actual virtual machines connected to both of these MikroTiks and see if we can actually do some cool stuff. So there is one more thing I'd like to bring up before we actually move on and test the solution. And that is we also need to make sure that we have the relevant firewall policies to allow the traffic. Now we know that we have policies here in the IPSEC section. However, our MikroTik's own firewall might unintentionally do stuff with the traffic if we have stuff like NAT rules or anything else happening here that could be blocking or dropping the traffic. I've actually seen this happen a lot with many of my other viewers that ask me for help. And then it comes down to them just not having a proper NAT rule to accept the traffic for that firewall or for the IPSEC. Now it's very weird because you're doing this via the NAT tab, but you're not actually going to NAT any traffic. You're just going to set the traffic to be accepted. So you're kind of telling your firewall, don't do anything with the traffic, just accept it. And then the IPSEC side of the router can then do with the traffic what it needs to do. So if you don't have these rules, you might have issues. So I'm just going to show you how to implement them quickly. And it's really as simple as going to your IP firewall, going to your NAT tab, hitting the plus, and then just specifying. It is a chain, is the source-based NAT. Your source address will be your local address. So on TNB Lab 01, it is 172.16.10.0/24. And then my destination address is going to be the remote side's address range. So 172.20.0/24. So I'm just going to navigate to the action. So instead of with a normal NAT rule where you might masquerade or source NAT the traffic, you're just going to accept the traffic now. All you're going to do, you're going to hit apply. Once you've applied this new policy or firewall rule that's been added, just move it to the very top. It needs to be the first rule that gets referenced, because if the normal NAT rule still gets referenced first, it could still cause issues with you connecting, even though you've got this rule. So now it will be the first in the sequence. And in essence, all it does is it says anything from my local subnet to the remote subnet, accepted. That's all it does. So now the traffic can be handled by the IPSEC side of the firewall. Similarly, we can do this on the command line by just going IP, firewall, NAT, add, chain is source NAT, source address is our local subnet. So this is not TNB Lab 02, obviously. So 172.16.20.0/24. And our destination address, which is going to be 172.16.10.0/24, with the action being accept. Now the command line does have a nice little trick that you can use to move this to the very top. I just want to see what that command was. I think it is move. It's not move above. Let's check. Place before. That's what I want. So you can tell this to place it before 0, and that will in essence just make it the very first firewall policy to be referenced. So I'll hit enter. And now if I do an IP firewall NAT print, we can see what the order is. And then I can see I actually do have a NAT rule for this already here. So now I've got it twice, but what it's doing is it's allowing that traffic so that it doesn't first get natted out via Ether1. So this is also just a bit of a prerequisite. If you don't have that in place, you might run into some issues with the traffic again. Sorry, I'm making this such a hard point, but this is the thing that usually gets MikroTik users when it comes to configuring IPSEC tunnel. All right, so let's continue on with the actual testing. All right, so here we're at the virtual machines, and I've got a Kali Linux box that's connecting to the MikroTik 2, and then I've got a Windows 7 machine that's connecting to my MikroTik 1. Or it might be the other way around. Let's quickly see what IP address is on my Kali Linux box. We can see that by just connecting here. Let me just full screen this as well so it doesn't look too weird. Let's do an ifconfig. And here I can see this is actually connecting onto MikroTik 1. Sorry. So from this Kali Linux box, let's just see, can I ping 172.16.20.1, which is the LAN address of Site B's MikroTik. And that I can ping, so that is awesome. I know that my site-to-site's working and I can actually get to the remote subnet. Let's see, can I get to a host behind that MikroTik? So a computer that's connecting behind MikroTik 2. And I can get to a remote host as well. So this is awesome. This makes me actually very happy. So let me just get out of there and let me go into this Windows machine. And inside this Windows machine, this is actually just a Windows 7 machine. As you can see, it's just like installed. It doesn't run anything. And I'm not going to license this because this is just for testing stuff. But I do have Winbox running on this. And then on this Windows machine, first I'd like to see my neighbor is 172.16.20.1. Awesome. So let's also just go to command prompt on this Windows machine. From it, can I ping 172.16.10.1, which is the MikroTik router 1 or TMBO1, so I can ping that MikroTik. Can I ping the Kali Linux box? Obviously I should be able to because I can get there from the other way. So last thing I want to check, and this might be very cool, is can I access TMBO1 over the IPSEC tunnel? So let's do 172.16.10.1. Let's try and connect. Awesome. So I can connect for management over an IPSEC tunnel on Winbox. So this is another way to just secure our management as well, because you could restrict access only over private or IPSEC subnets instead of over the public internet for management purposes. So now you can get to your MikroTik as well on the remote end using the IPSEC tunnel. This is so cool. So this is how we can configure an IKV2 tunnel. It's using some basic options. There is additional stuff you can do with security, obviously, but I just wanted to make sure that you can see how you can configure a very basic site-to-site VPN using MikroTik. So I hope you've enjoyed the video, and I'll catch you guys in the next video. And I'd like to also just thank my YouTube and Patreon members. You guys are supporting the channel tremendously, and I appreciate it so much. Anyways, guys, see you in the next one. Bye bye.